For the first time in Earth's history, the world felt dry. The endless swamps of the Carboniferous were fading. Vast forests that once covered the continents began to break apart, replaced by open landscapes, deserts, and seasonal environments. The planet was changing its rules, and life had to change with it. This was the beginning of the Permian period, around 299 million years ago, and it marked a turning point unlike anything before it. The age of giant insects was ending. As oxygen levels in the atmosphere slowly declined, massive dragonflies vanished from the skies. Enormous millipedes retreated into extinction. The humid, swampy ecosystems that supported them dried out. But while one world collapsed, another rose. Reptiles began to dominate the land. Unlike amphibians, reptiles were no longer tied to water. Their skin resisted drying. Their eggs could survive on land. Their bodies conserved moisture and energy in ways earlier animals never could. This made them perfect for a harsher Earth. As climates became more extreme, reptiles spread across the continents, filling niches left empty by collapsing ecosystems. They were small at first, fast, adaptable, and unstoppable. The Permian world was vast and alien. All major landmasses were slowly merging into a single supercontinent, Pangaea. This reshaped the planet. Interior regions became brutally dry. Seasonal temperature swings intensified. Monsoon-like storms battered coastlines. Life near the center of Pangaea endured scorching summers and freezing winters. While coastal regions faced violent weather patterns, only the toughest survived. Plants adapted by evolving seeds. Seeds could remain dormant during droughts and sprout when conditions improved. This allowed forests to return, but they looked different now. Conifers replaced swamp trees. Thick bark replaced soft tissue. Needle-like leaves replaced broad ones. The land was no longer gentle. Herbivores followed the plants. Early reptile-like animals evolved powerful jaws to chew tough vegetation. Their teeth became specialized, allowing them to process food efficiently and extract energy from harsh plant material. This supported larger bodies. For the first time, land animals began reaching truly massive sizes. Among them were the synapsids. They did not look like mammals yet, but they were something new. They had differentiated teeth, more upright postures, stronger jaws. These creatures were not reptiles. They were the ancestors of mammals. And during the Permian, they ruled the land. Predators evolved to hunt them. Carnivorous synapsids developed large skulls, powerful bites, and sharp teeth designed to tear flesh. Some walked with semi-upright limbs, allowing faster movement and greater endurance. For the first time, land ecosystems resembled modern ones. Predators hunted prey. Prey evolved defenses. Territories mattered. Earth had entered a mature age of animals. But beneath this apparent success, danger was building. Volcanic activity increased. Climate systems destabilized. Ocean chemistry slowly shifted. Life was thriving, but it was fragile, and it had no idea what was coming. By the late Permian, Earth was approaching a breaking point. Temperatures rose sharply, oceans warmed and lost oxygen. Carbon dioxide levels spiked. Forests began to die, and when plants collapsed, everything else followed. This was not just another extinction. This was the greatest catastrophe life had ever faced, and it would nearly erase everything that had taken billions of years to evolve. The disaster that ended the Permian did not arrive suddenly. It crept in. At first, life adapted as it always had. Animals migrated. Plants shifted their ranges. Ecosystems bent but did not break. But beneath the surface of the planet, something enormous was awakening. In what is now Siberia, the Earth's crust began to split open, not with a single eruption, but with thousands. Over hundreds of thousands of years, vast volumes of molten rock poured onto the surface in an event known today as the Siberian Traps. Lava did not explode upward like a volcano. It flooded outward, covering the land in layer after layer of basalt. These eruptions released unimaginable amounts of gas: carbon dioxide, sulfur dioxide, methane, the atmosphere began to change. Carbon dioxide trapped heat, driving global temperatures upward. The planet warmed rapidly, far faster than most organisms could adapt. At the same time, sulfur dioxide created acid rain. Forests weakened, soils degraded. Rivers carried toxic runoff into the oceans. The land was under assault. As temperatures rose, polar ice vanished. Sea levels fluctuated violently. Weather systems became extreme. Droughts devastated the interiors of continents. Floods ravaged coastal regions. Seasonal cycles broke down. Animals struggled to find stable habitats, but the worst damage was happening in the oceans. Warm water holds less oxygen. As ocean temperatures climbed, oxygen levels dropped. Vast regions of the sea became suffocating dead zones where most marine life could not survive. Entire ecosystems collapsed silently beneath the waves. Corals died. Shellfish vanished. Fish suffocated. The food web unraveled from the bottom up. As oxygen disappeared, something even more dangerous spread. Anaerobic bacteria thrived in low-oxygen environments. These microbes produced hydrogen sulfide, a toxic gas that smells like rotten eggs and is lethal in high concentrations. The oceans began releasing poison. Hydrogen sulfide bubbled into the atmosphere, damaging the ozone layer and allowing harmful ultraviolet radiation to reach the surface. The sky itself became hostile. Plants weakened under heat stress and acid rain. As vegetation declined, carbon dioxide removal slowed, accelerating warming even further. A feedback loop had begun. More heat killed more plants. Fewer plants trapped less carbon. Even more heat followed. The system spiraled out of control. On land, animals began to die in massive numbers. Large herbivores collapsed first as food supplies dwindled. Predators followed shortly after. Fossil records show once thriving ecosystems reduced to near emptiness. Entire regions became biological deserts. In the oceans, the devastation was almost total. An estimated 96% of marine species disappeared. Trilobites, which had survived for over 270 million years, went extinct completely. Reef ecosystems vanished. Many entire groups of animals were erased forever. This was not a reset, it was near annihilation. On land, roughly 70% of vertebrate species vanished. Insects declined sharply. Forests disappeared. Soils eroded into barren landscapes. Earth came closer to lifelessness than at any point since the earliest days of life itself. And the extinction did not end quickly. For hundreds of thousands of years, conditions remained hostile. Heat lingered. Oxygen remained scarce. Recovery was impossible. Life was trapped in survival mode. Those that endured did so by chance as much as adaptation. But even in this darkness, evolution did not stop. A handful of lineages survived. Small animals, burrowers, generalists that could eat almost anything. They waited. When volcanic activity finally slowed and the atmosphere began to stabilize, Earth emerged into a changed world. The old rulers were gone. The future was empty. And whoever survived the Great Dying would inherit the planet. A world that emerged after the Permian extinction was almost unrecognizable. Where forests once stood, there were vast stretches of barren land. Where oceans once teemed with life, there were long periods of silence. The planet was alive, but only barely. This was Earth's closest brush with total biological collapse. And yet, life endured. The survivors of the Great Dying were not the strongest or the largest. They were the most adaptable. Small-bodied animals with simple needs endured where giants could not. Creatures that could burrow into the ground escaped heat and toxic air. Animals that could eat almost anything survived when specialized feeders starved. Survival was no longer about dominance. It was about flexibility. Among the survivors were a few lineages of synapsids, the distant ancestors of mammals. These creatures were small, agile, and opportunistic. They hid in burrows, emerged at night, and avoided the brutal daytime heat. Their world was harsh, unpredictable, and dangerous, but it shaped them. Reptiles also survived in small numbers. Early archosaurs, a group that would later include dinosaurs, crocodiles, and birds, persisted quietly through the aftermath. At the time, they were not dominant. They were background animals, but they possessed traits that would soon matter greatly: efficient lungs, upright posture, endurance over long distances. They were built for a changing world. The Triassic period began not with abundance, but with emptiness. Ecosystems had to be rebuilt from scratch. Plants were the first to return. Hardy seed plants spread across the land, stabilizing soils and creating the foundation for recovery. Forests returned slowly, patch by patch, over millions of years. Only once plants recovered could animals follow. In the oceans, recovery was even slower. Many marine ecosystems had been erased completely. Reefs did not reappear for millions of years. Fish populations remained sparse and fragile. But evolution had space to experiment again. New groups of marine reptiles emerged, returning large predators to the seas. These animals breathed air, but hunted underwater, filling ecological roles left vacant by extinction. Life was rebuilding, but it was doing so cautiously. On land, competition intensified as new species evolved to fill empty niches. Predators grew larger. Herbivores diversified. Food webs slowly regained complexity. But this time, the balance was different. Synapsids, once dominant before the extinction, struggled to regain their former control. Archosaurs adapted faster, moved more efficiently, and tolerated heat better. The tide was turning. One key advantage archosaurs possessed was their posture. Unlike the sprawling limbs of synapsids, many archosaurs walked with limbs positioned directly beneath their bodies. This allowed more efficient movement and better breathing while running. In a hot world, efficiency mattered. Those who wasted less energy survived longer. Over time, archosaurs diversified into multiple forms. Some became fast bipedal hunters. Others became large quadrupedal predators. Some remained small and nimble. They were experimenting, and slowly, almost unnoticed, they were winning. Synapsids did not vanish, but they were pushed into the margins. Many became smaller, more nocturnal, more secretive. These pressures would shape their future in unexpected ways. Traits like insulation, faster metabolism, and parental care began to emerge. Traits that would one day define mammals. By the late Triassic, Earth had stabilized enough to support large, complex ecosystems again. Forests covered vast regions. Rivers carved stable paths. Oceans supported growing food webs. Life had recovered, but it was not the same life as before. The stage was set for a new kind of dominance, one that would define the next 160 million years. The age of dinosaurs was about to begin. The rise of dinosaurs did not happen overnight. For millions of years, they lived in the shadows of other reptiles, small and easily overlooked. The Triassic world was still dominated by a mix of survivors from the Permian, including large synapsids and early reptilian predators. Dinosaurs were present, but they were not in charge. Early dinosaurs were modest creatures. Most were small, lightweight, and fast. Many walked on two legs, freeing their forelimbs for grasping or balance. Their bones were hollow and strong, allowing efficient movement with less energy. They were not yet giants. They were specialists. What truly set dinosaurs apart was not size or strength, it was efficiency. Their upright posture allowed them to breathe while running. Their hips and legs were built for endurance, not short bursts of power. Their bodies shed heat more effectively than sprawling reptiles. In a hot, unstable Triassic world, these traits were decisive. While dinosaurs were refining these advantages, the rest of the world faced another crisis. Around 201 million years ago, massive volcanic eruptions occurred as the supercontinent Pangaea began to break apart. Lava flooded across vast regions, releasing enormous quantities of carbon dioxide into the atmosphere. Temperatures spiked, oceans acidified, ecosystems collapsed. This event triggered the Triassic-Jurassic extinction. Many of the dominant animals of the Triassic vanished. Large synapsid declined sharply, crocodile-like predators disappeared. Numerous reptile lineages were erased. But dinosaurs survived. And when the dust settled, they found themselves in a world with little competition. The Jurassic period began with opportunity. Forests spread widely across the continents. Climate conditions became warmer and more stable. Food was abundant. Dinosaurs diversified rapidly. Some grew enormous, evolving long necks and massive bodies to feed on high vegetation. Others became swift, agile predators, hunting smaller animals in packs or alone. The Age of Giants had begun. Herbivorous dinosaurs reshaped landscapes. Their feeding patterns altered plant communities. Their massive bodies trampled vegetation and carved pathways through forests. Predators followed. Large theropods evolved powerful jaws, sharp teeth, and keen senses. They became apex predators, ruling their territories through strength and strategy. Dinosaurs dominated land ecosystems for one primary reason: they adapted faster than their competitors. Whenever climates shifted, sea levels changed, or environments transformed, dinosaurs diversified instead of collapsing. Their diversity was their armor. Meanwhile, mammals were still present, small, furry, mostly nocturnal. They lived in burrows, climbed trees, and avoided direct competition with dinosaurs. Though insignificant in size, they were quietly evolving traits that would matter much later. By the middle of the Jurassic, dinosaurs were everywhere, from polar regions to equatorial forests. From dry inland plains to coastal environments, Earth had become a dinosaur planet, and it would remain that way for over 150 million years. But even at the height of their dominance, the dinosaurs were not invincible. The same planet that had nearly wiped out all life before was still changing, and once again, disaster was waiting. By the time the Cretaceous period began, dinosaurs had already ruled the Earth for tens of millions of years. But the Cretaceous would not simply continue their story. It would transform it. The continents were no longer locked together. Pangaea was breaking apart, drifting into the shapes we recognize today. New oceans formed, shallow seas flooded the land, and coastlines stretched for thousands of miles. This created new environments, and dinosaurs adapted to all of them. One of the most important changes of the Cretaceous had nothing to do with dinosaurs themselves. It involved plants. Flowering plants, known as angiosperms, appeared and spread rapidly across the planet. They produced fruits, seeds, and flowers, changing ecosystems from the ground up. This botanical revolution reshaped life on Earth. Herbivorous dinosaurs evolved new ways to feed. Some developed complex chewing teeth to grind tough vegetation. Others grew beaks, dental batteries, and powerful jaws to process plants efficiently. Entire new dinosaur groups emerged, perfectly adapted to these new food sources. Predators responded. As herbivores diversified, carnivorous dinosaurs followed, evolving sharper senses, improved hunting strategies, and stronger builds. Some became enormous apex predators. Others specialized in speed, stealth, or intelligence. The Cretaceous was the peak of dinosaur diversity. Armored dinosaurs with heavy plates and spikes. Horned dinosaurs with elaborate headgear. Duck-billed dinosaurs that traveled in massive herds. Feathered dinosaurs that blurred the line between reptile and bird. Dinosaurs were no longer just dominant, they were refined, and among them, something remarkable was happening. Feathers, originally evolved for insulation or display, became tools for flight. Birds emerged from small feathered theropod dinosaurs. They took to the skies, exploiting new niches and escaping predators. For the first time, dinosaurs ruled not only the land, but the air. The oceans were just as alive. Marine reptiles like mosasaurs and plesiosaurs became the top predators of the seas. Sharks diversified. Fish grew larger and more specialized. Life was flourishing in every corner of the planet. Meanwhile, mammals were still surviving quietly. They diversified into burrowers, climbers, swimmers, and gliders. They evolved sharper senses, more complex brains, and faster reproductive cycles. They were still small, but they were ready. The world of the Cretaceous was warm and rich. Sea levels were high. Forests stretched across continents. Polar regions were ice-free and teeming with life. It seemed like a golden age. But beneath this abundance, the planet was once again becoming unstable. Volcanic activity increased, climate systems fluctuated, ecosystems grew fragile, and far beyond Earth, something was moving silently through space. An object, tens of kilometers wide, was on a collision course with the planet, and nothing on Earth knew it was coming. For millions of years, life had adapted to Earth's changing rhythms. But this time, the change would not be slow. It would be instant. 66 million years ago, a massive asteroid slammed into what is now the Yucatan Peninsula. It was moving faster than a bullet. When it hit, the energy released was greater than billions of nuclear bombs detonating at once. The impact carved a crater over 180 kilometers wide. Rock vaporized, the ground liquefied. Shockwaves rippled across continents, triggering earthquakes and volcanic eruptions thousands of kilometers away. Within minutes, molten debris was launched into the atmosphere. Raining fire fell across the planet. Forests ignited. Oceans boiled near coastlines. Any animal close to the impact died instantly. But the true devastation came after. Dust, ash, and sulfur filled the sky, blocking sunlight for months, possibly years. Temperatures plummeted. Photosynthesis collapsed. Plants died. And when plants died, the food chain unraveled from the bottom up. Herbivores starved. Predators followed. Ecosystems that had taken millions of years to build collapsed in a matter of weeks. Dinosaurs, once unstoppable, vanished, not all at once, but inevitably. Only one dinosaur lineage survived: the birds. Small, feathered, adaptable, and capable of flight, they endured where giants could not. Dinosaurs never truly went extinct. They changed. In the shadows of this catastrophe, mammals emerged. They were small. They were flexible. They reproduced quickly. And in a world stripped of giants, that was enough. With dinosaurs gone, ecosystems reopened. Forests regrew. Oceans stabilized. And mammals began to explore niches that had been closed to them for over 100 million years. This was not the end of life. It was a reset, a brutal one, but a necessary one. Every mammal alive today, including humans, traces its success back to this single moment, a moment of destruction, a moment of opportunity. The age of dinosaurs had ended. The age of mammals had begun, and from that opening, everything that followed would eventually lead to us.